you should have. That is Algebra 1 and Algebra 2 material, all of this. Algebra 1 technically, but I don't know what's being taught in Algebra 1 now. It's ridiculous. Okay. We are basically going to talk about all of this while we do notes here, but I just wanted to get you remembering some things. Today we're talking about all kinds of linear equations. So here we go. Example 1, find the equation of the line. The basic definition, the basic directions rather, would be find the equation of the line. They say find the slope-intercept form of the equation of the line. That is them simply telling you your final answer should be in slope-intercept form. So when you're done, you want to have the y by itself. That's all they're telling you. You don't have to start with that formula. You can use something else. We also want to sketch the line. So combines a lot of, I just tested this in Algebra 2 yesterday, actually, or today, this morning. We're reviewing it again. The third time you've probably done this. And in fact, writing equations of lines is a huge thing. And I don't know if I've mentioned to you guys before, but I do calculus for fun at home. In all of my spare time with my husband, yeah. He took it for fun one year, years and years ago, before BC, before children. So before Christ. No, before children. And but yeah, he was retaking it just for fun. And his teacher was terrible, so I was basically his teacher. But at any rate, but I digress. I've been doing it to remember what sorts of algebra things we want to make sure that we cover. And a huge part of the beginning of calculus is actually writing equations of tangent lines. So we use calculus to get the slope, and then we use equations of lines to write the equation of the tangent line. So it's kind of a cool thing. All right, so here we go. We want to find the equation of this line with the given point and slope of a quarter. If they give you the point and the slope, what form should you use? Point slope form. Very good. That's why it has that name. Okay? Point slope form is what? Y minus y1 equals m times the quantity, x minus x1. Very good. Okay. So we can go ahead and plug in the information that we have here. Y minus what? 2 equals 1/4 times the quantity x minus 8. Very good. We can go ahead and distribute. 1/4 times x is 1/4 x. What's a fourth of negative 8? Negative 2. Good. And then we can go ahead and add 2. So I get y equals 1/4 x plus 0. Do I need to write the plus 0? No. But it is nice to have it there just to sketch the line. So I'm going to sketch this line. Where do we begin if I was going to sketch this line? 0. That's a B for begin here. The B is 0. So we begin at 0 on the y-axis. And then what does our slope of 1/4 tell me to do? Up 1, right 4. Up 1, right 1, 2, 3, 4. Up 1, right 1, 2, 3, 4. Right there. And there is our lovely equation of our line. 2 points determine a line. That's all you need. Okay? Got 2 points, connect the dots. You're done. Now, you have a graphing calculator. Your graphing calculator can be really helpful to check equations of lines. So in y1, I'm going to go ahead and write my equation. And as I graph that equation, hold on, 2, 6, okay. I can graph that equation. First of all, the overall look of the line pretty close to what I sketched. What I really would like to do is I would like to check that it passes through this point, because it should pass through the point 8, 2. Ladies and gentlemen, it is so easy to check an ordered pair. Use trace. Hit x equals 8. And hit enter. And sure enough, it passes through the point 8, 2. So use trace to check your ordered pairs. Always, always, always. That is a really easy thing to do. Okay. Letter B. I have 2 ordered pairs. What do we need? Slope. So we need to find that slope first. How do you find slope? y2 minus y1 over x2 minus x1. So 5/4 minus 1/2 over 1/2 minus 2. Oh, can I write 4/2? What did I do? Well, common denominator. Yeah. So I did it in my head. And that's kind of a useful thing to do. And in fact, this is what we do in calculus all the time, is add and subtract fractions. That's like 90% of calculus. So if you can, I know, right? If you can convert that, 4/2, 4 divided by 2 is 2, right? So this is an equivalent way to write it with equivalent bases, which means I can do the same thing with the 1/2. 1/2 would be 2/4. If I were to write that with a denominator of 4, yeah? 2/4 reduces to 1/2. So that's an equivalent fraction, and you can certainly practice that. I encourage you to do that. All right, or you can do the whole multiply to get a common denominator thing, but really work on doing that stuff in your head. 5/4 minus 2/4 is 3/4, and then 1/2 minus 4/2 is -3/2. Now I have a fraction divided by a fraction. What should I do? Keep change flip. 3/4 times -2/3. Multiply by the reciprocal. And we get -1/2. -6/12, which reduces to -1/2. Lots of fractions, ladies and gentlemen. It is imperative that you know how to work through fractions. And if you can't, don't be scared. You've got a calculator that uses it. You can math frac all day and night. Okay? Okay. All right. Now, we have a slope and a point. Does it matter which point we use? Doesn't matter. Pick a point. I like the first one. So I'm going to plug in to slope, point slope form. Y minus what? 1/2 equals m. -1/2 times the quantity x minus 2. Very good. I'm going to go ahead and distribute. -1/2 times x is -1/2 x. -1/2 times -2. +1, I'm going to leave it as +2/2. Why? I'm about to add the 1/2, so I'm thinking ahead a little bit and knowing that I might as well keep my denominator of 2. So -1/2 x, 2/2 plus 1/2 is 3/2. And again, this is something, equation of a line, that you can absolutely verify on your calculator. -1/2 x plus 3/2 on my calculator. And what am I going to check? How do I know if I got this equation right? What should it pass through? These 2 points, both points. It should pass through both ordered pairs. So I'm going to go ahead and graph that. And I'm going to use trace And I'm just going to plug in the x value too, and it spits out a 0.5. So that one works. And if I plug in a 0.5, it spits out 1.25, and that's the same as 5/4. Okay? So you can easily check those order pairs to make sure you did it correctly. All right, check using trace. Check points. Using trace. Really good thing to do there. Okay? Again, you want to be good with your calculator, ladies and gentlemen. It can be really helpful. All right. Last thing. Ejemplo 2. Write the equation of a new line. Parallel to the given line and perpendicular. Passing through the given point. Write the equation of a line. Parallel and perpendicular to the given line passing through the given point. Okay, ladies and gentlemen, tell me about parallel lines. They have the same slope. Same slopes. Tell me about perpendicular lines. Opposite reciprocal slopes. What does that mean, opposite reciprocal? What does opposite mean? With the opposite sign. Okay, so opposite means one of them's positive, one of them's negative. Those are opposites. Okay? One's positive, one's negative. What does reciprocal mean? Flip the fraction. Okay? Yes, the inverse. Another appropriate word. Opposite reciprocal. Change the sign, flip the fraction. If both of these things are talking about slopes, what do I need to do to the given line? We need to find the slope. How are we going to find the slope? Yeah. Solve for y. Put the y, get the y by itself so it's in slope intercept form. So what should we do? Subtract 2x. Okay, so we have 4x equals negative 2x plus 8, and then divide everything by 4. So I get y equals negative 1/2 x plus 2. So what's the slope of this original line? Ooh, slope is just the number in front. Negative 1/2. Okay. So this is the original slope, and so to write the equation of a parallel line, I want to have a parallel slope. So my parallel slope, that is the symbol for parallel. Did your geometry teachers use this symbol ever?
Nah.
That's disappointing to hear. This is the symbol for parallel. All right.
They should just say train tracks.
All right. So what slope should we use if we want a parallel line? Same slope. Passing through what point? Negative 4, 5. All right. If I have a point and a slope, what form should I use? Point slope form. Y minus y1 equals m times the quantity x minus x1. Yes, you do have to memorize that. You will be tested on it. Y minus what? 5 equals negative 1/2 times the quantity x plus 4. Very good. Minus a negative 4. Minus a negative 4 is going to turn to a positive 4. then we can distribute. So we get negative 1/2 x. What's negative 1/2 of 4? Negative 2. And then we can add 5. So we get y equals negative 1/2 x plus 3. What's our goal with writing this line? Parallel to the given line. Can I check that?
Yeah.
How?
Graph it.
Right, when in doubt, graph it out. Well, should I just graph this line or do I want a comparison line? Yeah, we want a comparison. So I'm going to graph both equations. We have the original equation and this equation. And I can graph those, both equations. And you can see that, yes, indeedy do, they are parallel. Okay? You can also test your ordered pair to make sure that your line passes through negative 4, 5. All right, perpendicular line. If I'm going to have a perpendicular line, I need a perpendicular slope. This is, that would be slope, rather. Okay. This is the symbol for perpendicular. You seen that one before? Yes? Well, that's good. All right.
Nah.
All right, what is the perpendicular slope going to be? 2, positive 2. Change the sign, flip your fraction. So you can think 2 over 1, but 2, really. And we're passing through that same point, negative 4, 5. So again, we're going to plug into point slope form. Y minus 5 equals my perpendicular slope times a quantity x minus a negative 4 or plus 4. What do I get when I distribute? 2x plus 8. Adding 5, we would get 2x plus 13. What was the goal of this line? What should it be? Perpendicular. Can I check it? Yeah, you sure can. 2x plus 13. So when I look at that perpendicular line, does that thing look perpendicular? Really? Really? No.
No.
So why doesn't it look perpendicular? Because my window is not a square. There are 20 tick marks from left to right and 20 tick marks top to bottom, equally distributed in a rectangle, not a square. All right? So I have a lovely tool on here, Zoom Square. Zoom Square makes the ratio of each little unit, the length unit and the width unit, the same so that it is a square. That looks better, right? That looks more like perpendicular lines. All right, Zoom Square. All right, ladies and gentlemen, do you have questions for me? We're good. That's it. Good. Today's a nice day. Is this the space to look at Friday? Dude, it feels like May.